Hello Precalculus student, this video is for chapter 5.1 still, but we are on topics of arc length and sector area of a circle. When an angle is measured in degree, and if we want to find arc length of a circle, so all of a sudden we talk about circle now. And then so we have a angle that we put in the center, right? So that where the vertex is in the center. And if this is an angle theta and we want to find, oh, how long is this or what is the area of this, that's a little tricky. You have to find the whole circumference and then figure out what fraction is this angle out of 360 degree, do the proportion like that, or and the same for area. But if theta is measured in radian, I'm going to underline this. If theta is not measured in degree but in radian, we have two very nice formula. The first is arc length formula. Most of the time the arc length is represented in not A but S. I don't know why. Maybe in Germany or other languages start with S. So S is equal to R theta. R is the radius. Theta is the angle in radian. And when I say theta, theta has to be the central angle. Area of a sector of a circle is all about circle, right? Is 1/2 r squared theta, like in the book, or 1/2 theta r squared. In both cases, theta is in radians, so you don't have to find like the circumference and do proportion and all those. Find arc length and area of a sector, the first example. So this is the basic one to use those. But we see that our central angles of this of circle is 140. It's not in radian. So whenever you see a thing that is not measured in radian, you have to change it into radian by multiplying of pi over 180. Right? So that would equal to, if I divide by 20, that would be 7 pi over 9 divided by 20 radian. Now I'm ready to use the formula, the two formula. The segment, this arc length S, would equal to R, which is 3 inches, 3 times 7 pi over 9. So that would be simplify 7 pi over 3, right? And put in the calculator, 7 pi over 3, let's do decimal, 7 pi, do not, oh, here, 7, you can just do pi over 3, so 7.33. And what unit do we have? It is an arc length, so it's in measured in inches, 7.33 inches. Okay, so this is the exact length, but this is the approximate length. What about area? The sector area, like this area, will be 1/2 theta r squared. So in our case, our theta is 7 pi over 9. So we say 7 pi over 9 times r. R is 3 squared. So this is 9, and this cancel. So it's 7 pi over 2 inches squared. And approximate as 7 pi over 2 over 2, 10.99. Oh no, did I do 3? Yeah. 10.11, we'll just say around 11 inches square. Okay, so just applying it, just remember you change it to the radian, because in real life problem they usually measuring degree in measuring angles in degree. A sprinkler spray a distance of 40 feet, so that's this right in the field. You can think of a field, but this is the sprinkler. It can do 40 feet. That's really long, and so and then it can rotate 100 degrees. So what area of sector? So it would be like a circular area, right? So what area of grass it will sprinkle? So it's 1/2 theta times r squared, right? So but theta is 100, so change 100 to radian by doing this first. So again, divided by 20, this will be 5, this will be 9. So it's 5 pi over 9. And then we would do, what is R? R is 40, right? So 5 pi over 9 times 40 square. And what is the unit? It's feet square. Okay, so write the unit properly. 1/2 times 5 pi, actually times 5 pi over 9, and then times 40 square. 1396.2 or 0.3. 1396.3 feet square. So pretty straightforward if you do that. And you don't have to find like the whole area and do proportion. Another use of theta is in measuring angular speed and linear speed. When a point moves along a line, we have only linear speed. But when a point moves on a circle, okay, so like could be someone driving a car. So this car is not going straight, but going along a circle. It would have still a linear speed v. We usually will talk about v, like how many miles per hour, how many feet per second, all those things. But it also have a angular speed. That means how many angle does it change? How many revolution does it go per hour? Right. So there's two different speed. One is angular speed. The symbol for it is omega. Is a Greek letter omega, just like W. So omega, because it's speed. Um, um, I think there's a typo here. Is how many angle it changed per time. So is the rotation per time. So it's theta over t. And velocity would be the distance s over r. So now s is actually r omega, right? So s is r theta. So if it is over time, gosh, I have another table here, divided by time. So this would mean that is r omega, because this is omega, right? R omega. So you have two formula. Omega is theta over t. V is r omega, or omega is v over r. Okay, so these are the two formula that you can use. Now, when we look at some rotations, so remember, omega is measured in radian per time, so per minute, per second, right, per time. But v is measured in distance, like inches, feet, is actually like feet or mile or inches per time. So there is a little difference. The units a little difference, but both of them are per time. So let's do some example. A vinyl record is 45 revolution. RPM is 45. That's those old days. And one revolution is 2 pi radian. So although they say the rate is 45 RPM, revolution per minute, the angular speed is actually 45 of revolution times 2 pi, and is radian per minute, right? This is per minute. So that would be 90 pi radian per minute. Um, Sometimes it's kind of odd to say 90 pi radian per minute. So actually, most people like to do revolution per minute, RPM. If the diameter of the record is 10 inches, so you can see that this is the record, is like rotating, and this is the diameter is 10 inches, so the radius is 5 inches, right? Then find the linear speed of a point. So we know that linear speed is equal to r omega, and we have omega already. Oh gosh, I should not do theta. Is actually omega. There's no theta here. So r omega would be r is 5, omega is 90 pi, and now all of a sudden I have inches per minute, because this is 5 inches and this has no units, so it's 450 pi inches per minute. And if you are to multiply it out, you will see how long is 450 pi. 450 times pi. be 1413.7. So approximately 1413.7 inches per minute. Then you can change it back to feet or whatever. The last question is about bike. So we know that, there is, given that there is a bike, the wheel has 26 inches diameter. So R is equal to 13 inches. So this wheel is traveling on the road, right? So it would be rotating, and then while it's rotating, it's going forward. So it's traveling 12 miles per hour. So that is the linear velocity v. What is the angular speed? How much are they spinning in radian per minute and also in RPM? Now you see that this is per minute and this one is per hour. So there's some kind of change of variable or change of units here. So first of all, let's write it down first. Let's write down change this to and also we see that we have an inches here, but this is mile. So this 12 mile per hours needs to change into inch and also needs to change into minute, right? So, but in a nutshell, if I want to find angular speed is what? Omega. Omega in radian per minute is equal to, because V is equal to R omega. So omega is V over R. So our V is 12 mile per hour. So 12 mile per hour. We could write it as 12 mile per hour like this. And then I divide it by R. R is 13. So times 1 over 13, right? But this is in inches. So I can't, this mile and inches doesn't change, cannot cancel. And also I want it to be in radian and also in minutes. So this is hours, so I have to first change the mile into inches, right? So I can actually cancel with these inches. So 1 mile, so I'll put 1 mile equal to 5280 times 12 inches is equal to 5280 feet, and 1 foot is 12 inches. So that's how we do inches. And I also need to change this hour to minutes. So I would put 1 hour here so I can cancel the hour and have 1 hour has 60 minutes. So this is what would will be the omega. So it would be equal to, put in the calculator, 12 times multiply across 5280 times 12 over the bottom is 13 times 60. Okay, so put in the calculator, I got 974.7. So this is radian per minute. After I cancel everything, I would have minute left over. So this is the first part. Find the speed in RPM. RPM would be how many 2 pi it is, right? So because 1 revolution is 2 pi, so 974.7 divided by 2 pi. So that would be 155 RPM, rounded, RPM, which is a more common way of saying angular speed. So that's all for 5.1.